Hi, in this video I'm going to do a comparison test between these two LiDAR scanner. This one is Chassis one from Share UAV and this one is the Eagle from 3DMakerPro. The Eagle was launched about 7 or 8 months ago and Chassis one is still on the Kickstarter. These two LiDAR scanner was sent to me by the manufacturer. Okay, let's talk about the physical of these two LiDAR scanner. Chassis one has a Livebox 360. It used the built-in IMU sensor, which is 4609. It has two cameras. It's a wide-angle lens camera, which is 2.3 megapixels. And the weight of the scanner is 950 grams. It has a battery inside of the handle, so you can have a spare batteries, and it will last for 3 hours in that specification. I haven't tested the longevity of the battery yet, but I think it's could be that long for 3 hours. The construction of the scanner, the battery handles and the body of the scanner is made from die-cast aluminum. It doesn't come with a tripod, but the handle is wide enough to place on the floor like this, but I don't think it's secure. Okay, now let's look at the Eagle. I have this for over 6 months now. I tested so many times. 3DMakerPro has updated their software. The latest one is the Ray Studio version 1.0.9, which improved the SLAM algorithm quite a lot comparing with the first version. The construction of the scanner is made from the plastic shell, and the handle is just the handle. There is no battery in here. The Eagle put all the batteries inside of the scanner unit so that you can mount it on the drone without to worry about the power. So this is the benefit of having all-in-one unit like this, and it also has the display touch sensitive input that you can use for initiating the scanner. You don't have to connect this to the phone. The weight is about 600 grams heavier than the Chassis one. So when you carry it for longer than 5 minutes, you start to feel the weight because it's top heavy. They put the battery inside here, while the Chassis one has a battery grip, which is quite balanced when you hold it for a long time. The version I have is the Eagle Max. It has 4 cameras, and each camera is say right here 48 megapixels, while the Chassis one has only 2.3 megapixels camera. And they have a standard version which costs around 4,000 US dollar, which is the same price as the Chassis one. After Kickstarter is going to cost the same as the Eagle standard version, but the Eagle has the RTK unit, but the copy that I have here doesn't come with the RTK, so I never actually tested with the RTK yet. I have scanned this house with the Eagle many times before, and I have decided to do a reshoot with the new software and the firmware update. For Chassis one, I have already made a video. These two scanners were scanned at the same walking speed, and I did exactly the same movement when I scanned the entire house. On the right is Chassis one, and on the left is the Eagle. If I move the wall to the left edge of my monitor, you can see that in this axis there's a gap here. It shows that there's some drifting on the second floor with the Chassis one. If I move it here, all the walls are in the same line on both sides. See here. For the Eagle, this wall has come out a bit. Cross section on the third floor. Move this up. The above point cloud will be from the Eagle, and the below point cloud is from the Chassis one. There's a lot of difference between these two scans. You can see the wall line from the Chassis one much clearer than from the Eagle, and I think it has a rotational drifting because the wall here has a very thick point cloud. That's because losing the precision when it's scanned, while the wall line from the chassis one is much thinner and clearer. Second floor. Okay, in the second floor is quite similar to the third floor, where the Eagle has a very thick layer of the wall, and chassis one does much better. All the walls are aligned and it gives 90 degrees. Okay, let's move to the first floor. Okay, so the difference is quite a lot between the chassis one and the Eagle. The Eagle has 48 megapixels RGB camera, but when I open up the image folder, it appears that the image size is 1000 by 750. That's only 0.75 megapixels. Okay, this is the image from the chassis one. The image size is 1920 by 1200. That is 2.3 megapixels, and they advertise their RGB camera for 2.3 megapixels, and they use all of the pixels for mapping the point cloud. Image resolution from the chassis one is 3 times higher than the image resolution from the Eagle. And the second difference is that the chassis one they use a non-color point cloud to build the color point cloud, so it has the same precision and accuracy. There's no difference between the color and the non-color version for the chassis one, but for the Eagle, the difference between the non-color, which is this one, and the color is quite different. This time I'm going to slice it. Eagle has issue with the rotational drifting. You can see this room is drifting. The wall is not parallel. This wall is not parallel. And also this wall is not parallel. For chassis one, you see this wall. It has a parallel wall. And for the Eagle color version, it shows only one line of the wall. And for the non-color, it shows like almost 2 lines, but difficult to distinguish. The second floor. The non-color version of the Eagle wall here is parallel, but the color version, it doesn't show that this is the wall. For the second floor, the non-color version for the Eagle, it does bear. The color version is failed to identify the walls in this room. And this is the C1, which is a perfect wall alignment. So for the Eagle, the non-color is still perform better controlling the drift than the color version. And for the chassis one, there is no difference between the color and the non-color. And you can notice one thing about the chassis one. The corner which is supposed to be sharp corner is appear to be a round corner, while the Eagle it's look a bit sharper than the chassis one for the corner. But you can see here that the wall thickness from chassis one is much thinner. That's why it can maintain a 1 centimeter accuracy, because the wall is very thin. Okay, so in conclusion, with this 3-story house, chassis one is the only LiDAR scanner that can scan this 3 floors in one pass without any drifting, rotational, and translation. Okay, in this comparison, I will test the scanning resolution on the facade wall in front of me. Okay, this will be the second example. The scan from the Eagle is on the left, scan from chassis one is on the right. I want to demonstrate how you are going to use the 3D scan data for reversing the facade. Because they both use the Livebox 360 and it's not the highest resolution LiDAR. Both of these LiDAR scanners require to use the RGB camera to help identify the position of the objects on the facade. And you can see here that the Eagle, it used a much lower resolution on the image, which is only 0.75 megapixels, while chassis 1 is using 2.3 megapixels. So the difference is quite a lot between these two. You can identify the position of the windows pipes using the RGB camera, while you cannot do the same with the Eagle. I walk at the same speed. The distance from the LiDAR to the wall is the same, and the difference is quite obvious that the chassis one can provide higher details on the wall than the Eagle. The other model of Share LiDAR scanner, Share S20, that one has 16 megapixels of the RGB camera, and chassis one, which is this one, has only 2.3. So I think that one, the Share S20, is going to give even more higher detail than this. The preview screen on chassis one is very fast. Okay, next, the final comparison, the scanning for the car in the parking. On the right is chassis one, and on the left is the Eagle. The chassis one gives a much higher detail in the color scan, while the Eagle, it gives a much lower detail. I mean, if you want to scan for the wall, the position of the window frames, the door frames, chassis one will give you higher detail that you can trace using your CAD software. See here, if you look at the top here, you can't even see the welding seam lines on the membrane here, which is very good for my work because I can reverse the fabric pattern for making a new fabric if someone lost the original drawing. So I can reverse it, and you can see here that the corner plates also display, and the position of the bolt even shows here 1 2 3 4 5 bolts. So if you spend time long enough on the scene, it's going to give you a higher detail, while the Eagle is give a higher noise level on the membrane surface here, and the detail on the car is not as good as the chassis one. Okay, let me crop just the car here to see if you can really use the scan from the LiDAR for scanning the car. I need more space. When scanning a car, you need 2 meters at least from the car. I don't have this space, so it's going to be an issue with the space, and I think I walk too fast. I should place the scanner on the floor. I mean, this is the starting point. You can see it here. Let me increase the point cloud size. See, this is starting point where I place the scanner on the floor. And you can see that give a very high detail when I place it on the floor. So it's good idea if you place it on the corners on the floor and wait for 10-20 seconds. It's going to give a denser point cloud. Let me check here. See, yeah, I think I can trace this shape for the car. Now these two manufacturers, 3DMakerPro and Share UAV, they both support the review sample for me to be able to make this video. I hope that in the near future, the 3DMakerPro can improve their software and the firmware, because they are using exactly the same sensors. I believe that if their commitment to to their software development, they can catch up with the chassis one. But for now, it's the spacing between these two is quite different. So when the 3DMakerPro or chassis one has new update software and the firmware, I will do a rematch to compare these two LiDAR scanners again. I made this video for the benefit of the consumer. I was not paid to do this video either by the 3DMakerPro or the Share UAV. Thanks you guys for watching. I'll see you in the next video.